Hey there! So we know already how to process data using Stream Analytics. Great! We know all those window functions like tumbling window, hopping window, and so on. But there is one topic that we missed so far, namely time handling. How do we handle time? And this is super important in case of streaming. So that's what I want to talk about today. The second thing is performance. So how do we know, how can we check if our stream solution is performant enough? And if we detect that something is wrong, how do we improve it? How do we fix this? So that's the topic for today. Let's get started. Alright, so let's start with handling time. Now, you might think that, well, time is not that important, so why should we care? And basically, it is important because, well, think of it like this. Depending on a scenario that you are implementing a solution for, you might care about a moment in time when the event was generated, when it was received in Azure, and when it was processed by Stream Analytics. And namely, in case of streaming, we can define two types of time that I would like to talk about. So first category is called event time. So event time. Or sometimes it is also called application time. So application time. And what is this? Well, basically, that's the actual time when the event happened, when it was produced by the event producer. So for example, when some action happened, that's the event time. The thing is that Azure, as it processes the events, it doesn't have a clue about the actual event time because it was generated outside of Azure. So if you would like to process, if you would like to include this event time in your processing, you would have to make sure that the event time is included in body of your messages. And if you recall my example, when I was playing around with those scores from YouTube, you should remember that I had this publish time as one of the properties inside my JSON data. And that's the event time. The second thing is arrival time. So we've got arrival time. And that's the time when event appeared in Azure. So depending on your architecture, it might be the time when it was inserted into event hubs queue or IoT hubs. Or if you're playing around with blobs, that's the time when the blob was modified. And actually, this distinction on those two types of times is super important. And think about some issues that you might see already when you think about both of them. So let's say that, well, we've got this diagram. Actually, let me move it a bit, like so. So we've got two timelines. The first one, the upper one, would be our event time. So when something happened. And the second one would be arrival time, when the event arrived in Azure. And let's say that we've got several events. So for example, let's have this one, this purple one, that was generated at some point in time and it was sent to Azure. And we will also have, let's say, yellow one, then blue one, and green one. So let's say 4 events were generated by some producer, whatever it is. No, we don't care about it. Now, those events have to be sent to Azure, so for sure there will be some latency already. related due to the network traffic. So let's say that in case of our first event, it was like this. We've got this small latency, so this is the latency, the difference in times when the event was actually generated, produced, that's the event time, and the time it was received in Azure, in Event Hubs, if we use this. Let's say that in case of our blue event and our green event, we've got similar latencies. So something like this. Well, actually, in case of green one, it was even bigger for some reason. However, let's say that the yellow one, well, it got some issues down the road. It was bouncing quite a lot through the internet until it finally arrived to Azure. So in its case, the difference between those two times is quite big. So this should already give you a hint about some of the issues that you will have. So first of all is this latency, this difference between those two times. And you should ask yourself a question: do you care about this? Because maybe you know, maybe you don't. For example, in my case, when I was playing around with those YouTube scores, well, I don't care. Because from my point of view, this difference, this latency is not that important, so I can ignore this. But let's say you're developing a streaming solution for high-frequency trading. And then this difference matters, because let's say that at this point, someone ordered some purchase of some stocks at specific price. And at this time, this request has been processed. But in the middle, the price of these stocks might have changed already. So here it might be lower, and then it went at the beginning it might have been higher, and then it went down, or the other way around. And in this case, you should make sure that you process the event according to the conditions that existed at the time the event was produced. So you should sell it or buy it for this price, not for this price, because it impacts the money. And whenever the money is included, you should probably care about time. So that's first thing, this latency. Do you care? Secondly, you can already see that the order of events between the generation and processing differs, because this yellow event it was in fact generated between this purple and green one, but as it arrived, it would be processed after the green one. So we've got some events that are out of order. And again, you should think, do you care? Is it important from your point of view? In my case, with those YouTube scores, I don't care, because I'm just calculating the average. And the average, it doesn't change based on the order. But if you're dealing with this, let's say this high frequency trading, then yes, you should process the events in the same order as they were generated. So you should pay attention to it. Then another issue that you might have is related to clock skews. So let's say that you've got multiple event producers, maybe some IoT devices. So these are those rectangles. And each of them has some internal clock, based on which they send the time, the event time. But maybe those clocks are not in perfect sync. And even though each of those IoT devices tries to send as accurate time as possible, they will be different because there's this not synchronized time between all of them. And then what? How do you handle this? That's yet another thing that you should take into consideration. Assuming, of course, that you care about the event time. Because if you don't, then you're done. You can forget about all these issues that I will be talking about. If you can process the events based on the arrival time, that's great. Your life is way simpler. And actually, that's what Stream Analytics does by default. If you do not specify it explicitly, it will process events based on arrival time, based on the time and order those events arrived. And because in the previous episode I didn't do anything special, that's how my data was processed. But if you have to include the event time, then you would have to modify your queries to explicitly tell Stream Analytics which property, which field contains the event time. And to do this, you would modify your queries and include this timestamp by property. So timestamp by, for example, in my case, it would be publish time, because that's how my event was, that's how my column was called, I believe. So let's double check this. So let's take a look at those pass-through outputs, how the data looked like. Yeah, so we had this publish time. That's the property, that's the column, that's the field that's included in the events. It was generated by the producer. So that's the actual time when the event happened. All right, so let me repeat those various times on a diagram to help you understand where those times are used and how they are used. So again, let's redraw our architecture. So we've got different producers like IoT devices, some streaming, and so on, whatever. Then this data is sent to IoT hubs, and I will not use icons today just to make it faster. So you've got some ingest. It might be IoT hub, it might be event hubs, or blob storage. So data flows like this, then it goes to, in our case, to Azure Stream Analytics. So Azure Stream Analytics. All right. And where those various times are available. So first of all, we've got event time. That's the time when event was generated. And the only party that knows these times is the producer. So event time is here. Event time or application time. Then once this event arrives to Azure, we would know its arrival time. Arrival time. And depending on a service that we use, it would be stored in a different property. For example, for IoT hubs and event hubs, it would be called event enqueued UTC time. For blob storage and data lake, it would be blob last modified UTC time. Then, when the event is processed by Stream Analytics, we would know processing time. Basically, when it was processed. Right? So that's where those various times appear. And actually, we can see those times, actually all of them, in our sample data. So let's go back to my JSON data that we processed last time. And in our case, this published time, this is my event time that was generated by event producer. Then we've got those regular properties that were also included. And then we've got some additional columns that were added throughout the processing. And the first one is this event enqueued UTC time. Basically, that's the arrival time. And because I used event hubs as the ingest part, that's why this particular column was used. And then we've got event processed UTC time. That's the time when this event was processed by Azure Stream Analytics. So all of this information is available. Apart from that, we also have this system timestamp property that actually we used in our query. So let me open the query. Yeah, for example, in the tumbling window example, we use this system timestamp to indicate window end time. So what is it all about? So basically, every event at every stage of the query in Stream Analytics has a timestamp associated with it. And the system timestamp system property can be used to retrieve it. And that's what we are doing here at this example. And for example, if we use those window functions, like we do here, we do grouping by window functions, then in this case, the system timestamp, it will return the end date of our window in scope of which a given event was produced. So that's how it works. All right, so, well, we know that we have those various issues we might have if we care about event time. If we don't, then you can forget about those events, those issues. All right, so what can we do about this? And fortunately, Stream Analytics has some policies that allow us to handle those things. So first of all, we've got something called late arrival policy. So that's the first thing. Late arrival policy. And in what cases it can help us? Well, again, let's take a look. Oh, come on. Let's take a look at our issues. We know that there will be always some latency associated with our events, a difference between the time event was generated and the time it arrived to Azure. So the question is, how long are we willing to wait for those events? 5 seconds, 1 second, or maybe 1 minute is still fine. So late arrival policy is something that allows us to configure this. And how does it work? So let me draw this nice diagram. All right, and let's say that on the horizontal axis, we've got event time. On the vertical one, we've got arrival time. And let's say that the scale of both axes is the same. So, one more time. Here, we've got the time when event was generated. And here, we've got time when event was received by Azure. And now, in ideal world, it would be something like this perfect line, which means that if we have an event, for example, here, it would mean that, well, it was generated at this particular moment in time, and instantly, at the same moment, it arrived to Azure. So there is no latency at all. But we know that it doesn't happen. There is always some latency, maybe minimal, but there is. So the question is, for how long are we willing to wait? And that's what late arrival policy is. It allows us to define this period. Let's say 10 seconds. That's how long we are going to wait for those events. Which basically means that we'll have something like this. So here, that's the difference of 10 seconds. And basically, if there is an event that is received within this marked area, it is fine. For example, in this case, oh come on. So in this case, it was generated at this particular moment in time. There was some latency, we can see the latency here, but it was still within the boundaries that we are willing to accept. So this event will be normally processed. Great. But what if we have an event, let's say, like here, which was received way too late compared to the time it was generated, right? It was late by this marked thing, by this marked period of time. So how do we do? How do we proceed with this event? And well, the policy, it allows us to configure two actions. Either we say, sorry, you are too late, we don't care about you, get lost. So it will be simply discarded and not taken into account. Or we might say, all right, you are too late, we know, it happens. So what we'll do, or what Stream Analytics will do, it will adjust this event, its event time, to look as if it arrived just in the last possible moment in time. So it would still fit into our late arrival policy. Now, I told you that it would adjust event time, and event time, that's the time when the event actually happened. So one important thing is that Stream Analytics will not update this original field that contains the event time. For example, in our case, it could have been this publish time. No, this field will remain unchanged because it cannot be modified. But what Stream Analytics will do, it will simply adjust the value that is returned by system timestamp property, right? So it would look as if this event was received, was generated at the proper time, right? I hope this is clear. So let me give you an example how it might look like. So let's have a table of event time and arrival time. All right, and let's say that we've got the first event that was generated at this particular moment of time, and then it arrived, let's say 5 seconds later. Now, because there is only 5-second difference between the time event was generated and the time event was received, everything is fine. It still fits into the policy. So nothing changes here. It is still being processed in a regular way. But let's say that we've got another event that was generated at 10 seconds past midnight, but it arrived late. So let's say it arrived 30 seconds later. So it's too much for our policy. And let's say that we decided that we don't want to drop those events, we want to adjust them. So what would happen would be that the timestamp, system timestamp property that would return the event time of this event would be modified to return the last possible time that would still fit into the policy. So it would be like this. Why? Simply because the difference between these two is equal to our policy, to the 10 seconds. Right? So that's the last possible moment in time, the latest one, when this event could have been generated and it would still fit into the policy. So that's one thing we can do to handle this latency. The first type of policies that we have. The second one is used to handle those events that arrived out of order. And it is called out of order policy. And how does it work? Well, here basically we define a buffer, a delay, that tells how long Stream Analytics should wait before it starts processing events after they were received. Let's say we set it to 30 seconds. So effectively, we add a delay, for, in our case, for half a minute, during which those out of order events might arrive, and if they arrive within this buffer, they will be automatically reordered by Stream Analytics. So they would be processed in a correct order, even though they arrived in a wrong order. Alright, so where can we set this? If we jump to Stream Analytics, that's my Stream Analytics job. That's the one that we used previously. We have this event ordering tab. And here we can define those policies, those values. So first of all, we can define this late arrival policy. And the tooltip says that, well, it basically explains what this policy does. And by default, it is set to 5 seconds. Similarly, we can set this out of order policy. And by default, it is set to 0 seconds. So out of order events are not reordered. And then for both of those policies, we can define what to do with events that don't fall within those time ranges. So we can either adjust them or say, goodbye, you will not be processed. So by using those two types of policies, we can solve those two types of issues that I was talking about. Alright, so that was time handling, the very important stuff. Secondly, let's say that we have our stream solution configured. It is working great, but, well, how do we know that it is performant enough? Well, obviously, if users start to complain, that it means that it's probably not fast enough, but probably we would like to know upfront that something is wrong. So how can we tell? And well, there are some metrics that we can observe. So in the case of Stream Analytics, if we go to the Overview blade, then to the Monitoring tab, you will see some key metrics, the ones that were selected by the product team to be the most important. And here we've got something called watermark delay. And basically, watermark delay, it simply put indicates the delay of streaming data processing job, or in other words, latency. And to simplify this a bit, you can think of it that it shows a wall clock difference between the time the event was generated and the time it was produced. Which means that if this watermark delay is going up, it means that events have to wait longer and longer until they are processed. Which means that probably our streaming solution doesn't have enough compute power to process all events in a timely manner. So this might be an indication that you have to do something with it. Alright, so once we know that something is wrong, then what can we do? And by the way, you can also take a look at this resource utilization metrics that tell you how much of the capacity you are using. Alright, so what can we do about this? So first of all, as always, we can just throw more money into the solution, just buy more capacity, more compute power. And in case of Stream Analytics, this compute power, it uses those streaming units. And streaming unit, basically, it represents resources that are allocated to execute your job. CPU and memory, simply put. And you can either just set them manually to some value, and Microsoft recommends start with a single streaming unit and then adjust it based on your observations. Or you could use dynamic scaling up and down based on some metrics. For example, you could define a rule that, let's say, if your watermark delay is bigger than 1 minute, then add more streaming units. And if it falls below 5 seconds, then just lower streaming units. Of course, you would adjust it to your needs. So that's one of the things that can be done. Just add more power to the solution by paying more. And please note that you might also need to go back to your ingest part. In our case, it would be event hubs, and add there more throughput units if the number of events that are sent to it is bigger than the total throughput. Alright, great. So, well, we can make it better by paying more, but no one likes this, except for Microsoft. So, what can we do else to make it work? And the answer is, let's parallelize our processing to make it faster. And how to do this? And please be advised that not every scenario can be parallelized. For example, let's think about mine. So what I was doing the last time was to analyze scores of various YouTube episodes. And because I was scoring the data per episode, it means that if I was able to split the work per episode, then it would be great. So I could make those averages in parallel and then just aggregate the results. But that was my scenario. Sometimes you will not be able to split the work, but hopefully in your case it will be possible. So what has to be done in order to parallelize the whole processing? And please remember that it would have to be done on every step of the processing. And we know that it starts with event producers. So we've got event producer that is generating those events. And those events are sent usually to event hubs. So we've got event hubs. Within event hubs, we know that we've got partitions. We didn't talk much about them until now. So those are partitions. And partitions are simply separate, let's call them queues, to which various events would be stored. So how is the data split into those partitions? So basically, when the event producer is sending data to event hubs, it might indicate, hey, please partition the data based on some column. And what is done under the hood is that this data uses some hashing function to distribute it to a specific partition. Basically the same approach, the same concept that we saw in case of hash distribution for dedicated SQL pools. So it would go like this. Now, unlike dedicated SQL pools, here we can define how many partitions we want to have. And number of partitions, it doesn't change the cost. It's up to us. Let's say that we decided to have 3 partitions. And let's say that in our case, we configured the event producer to partition the data by episode ID column. So the event producer, it only knows that this particular column will be used for partitioning, but it doesn't know where this data will physically land, because it's none of its concerns. It's the event hubs that does the magic. So if we do this, then we have a guarantee that events for the same episode would be available in the same partition. So for example, we are sure that events for episode, let's say 23, would be stored on this partition and none on another. Let's say events for episode 12 would be stored on this one. Events for episode 3 would be also here. And it's fine that multiple episodes would be stored on the same partition. That's fine. What is important, that events for the same episode are guaranteed to be stored on the same partition, whichever it is. Again, the same concept that we had in case of dedicated SQL pools. Now, if we know that all of the data that we need to calculate averages are stored on the single partition, then maybe this work could be parallelized. So instead of a single query that runs on the whole event stream, we could have multiple queries. And yes, that's what we do. So later on, after event hubs, what we have is Stream Analytics. So this is Stream Analytics. And here, if we know that our source, our event hub, is partitioned by a specific column, then let's tell this to Stream Analytics. And depending on the compatibility level of the Stream Analytics, it is done in a bit different way. So if we have the newest compatibility level 1.2 or higher, then it can be done at the time when we are defining the input for the event hub, for Stream Analytics. So that's my Stream Analytics job. We've got my first event hub input that points to event hub. And here, one of the properties that we could set is called partition key. So that's the one. And the tooltip says, if your input is partitioned by a key, and our would be, then it is recommended to specify that key here, as this optimizes performance of your job. So what I would do would be simply to add something like this, partitioned by episode ID. And what it will do effectively, it will simply make our query parallel. It would deploy multiple instances of our query. So these are our queries that we defined. And the best part is that each of the instances of the query would be grabbing the data from its dedicated partition from the event hub. So we would have one-to-one relation between the source partition and the query. So basically, this query would have to just partition the data, process the data from this partition, and so on. And because we know that our query can be satisfied by the data that lives in a specific partition, it is fine. That's why we can parallelize our query. Now, if you use older compatibility level than 1.2, then you would have to modify your query a bit and add this partition by statement. Partition by some column, right? In case of newer one, it has to be defined just as one of the input properties. Now, so if we have multiple instances of our query, does it mean that the total throughput changes? No. No. When we create Stream Analytics job, we have to provide this streaming unit. This one, right? How powerful this job will be. And even if we have multiple instances of the query deployed, this streaming unit count, it doesn't change. It still stays the same as it was originally. But the thing is that in case of those multiple instances of the query, those compute resources are utilized way more efficiently. And that's why the overall throughput, overall performance is better. You can compare it with multi-threading application and the single-threaded one. That both of them are executed on the same machine, but probably the multi-threaded one would be way faster. Alright, so we have one input partition, one instance of the query, and the last thing we've got to do is to have also partitioned output. So this is our output, whatever it is. And a rule of thumb is that number of input partitions here has to be the same as number of output partitions, and obviously the same as number of query instances, except for blob storages that has some relaxed conditions. So let's say that we would like to partition our output. And actually, we did this already, because we use this path property in our output that specified that we want to use episode ID as a directory. So we got multiple directories created. And I know that here we've got more directories than we've got partitions, but that's fine. In case of blob, this is fine. So here, oops, let me change the color. So it would be done like this. And basically, this whole scenario has a specific name. This is called embarrassingly parallel job. Embarrassingly parallel job. And that's the most performance design or solution that you can think of. That we've got this nice alignment between input partitions, number of query instances, and number of outputs. Now, I know that blob is specific here. So let me give you another example. So let's say that you are processing data from event hubs, you are doing something with it, and then again you are sending it to event hubs, to another one. And here, to make it embarrassingly parallel, you would have to make sure that number of input partitions is the same as number of output partitions. So for example, let's say that here you've got 8 partitions in the source, in the input, and then you would have to also have 8 partitions at the output, so they match. If you had, let's say, 16 partitions at the output, it will no longer be embarrassingly parallel. So it wouldn't be the best possible scenario. It would probably still benefit from some degree of parallelism, but it wouldn't be the best possible one. So that's how you can improve your performance. Alright, and one more thing that I would like to show you today is this visual designer. So if we go back to event hubs, to a specific event hub, let's say to my event hub, here you have under features this process data tab, which allows you to process your data using no code drag and drop experience. And you've got several scenarios available here that you could just use. Let's say that you would like to use this one. So process data from event hubs and save it to data lake on using Delta format. So we would just need to click start and start configuring this. So first of all, you would need to give a name to your Stream Analytics job, like job 1. It creates the job under the hood, and then you've got this visual designer, which you can use to just drag and drop various connections between various components and add some operations like some aggregations. So instead of writing SQL code, you would do this in a visual way. At the end, it would work in the same way as SQL-based version, but maybe for those of you who don't know SQL, it would be simpler. For me, it's not, but there is this possibility. Alright, and that's it for today, so let me summarize it. So handling time in stream processing is super important, especially that in some cases you have to process the data not by the time it arrived to Azure, but by the time it was generated at the source. And if you have to do this, then you might have to deal with various issues like the latency between those two times, or due to the fact that some events might arrive out of order. So how do you do this? How do you handle this? And Stream Analytics has those two policies, late arrival policy and out of order policy. It allows you to configure those edge scenarios and define what to do with events that don't fall within the boundaries defined by those policies. Secondly, You should pay attention to overall performance of your solution. And you can use various metrics to observe it, like this watermark delay. And if you would like to have the best possible performance, you should go into this embarrassingly parallel job, in case of which the whole processing would be parallelized. But to make it work, you would have to make sure that the number of input partitions and output partitions is the same, is aligned. And that's it. Thanks for watching and see you next time. Take care.